So today we're going to briefly introduce pygame and take a look at some of the basic tools. So on the pygame website, you have access to the latest releases, how to update pygame or install pygame if you have Python on your computer already. The main thing is the documentation. So in the documentation, there's access to lots of information about all the different kinds of things that you can do with pygame. We're only going to focus on portions today. These are very basic portions, but as you spend more time with pygame, you'll spend a lot of time with the documentation. So pygame is a two-dimensional system. It's completely X and Y coordinate based. You can mimic things in 3 dimensions by drawing things that are smaller, by making things draw something partially on top of something else to make it look like it's in front of it, some other kinds of things to fool the brain, fool the mind into thinking that something that is fundamentally 2-dimensional is 3-dimensional, but it's really for 2-dimensional purposes. The XY in pygame, the XY grid is based again on an origin, a starting point, and in pygame that is at the upper left-hand corner. In the traditional mathematical setting, you draw the x axis and the y axis, and so the origin is somewhere in the middle of something. In this particular case, the origin is the upper left-hand corner. And then the positive direction is x to the right. So positive x is to the right, just like you would expect. But in pygame, positive y is down. So there are reasons for this behind the scenes and extended reasons related to 3-dimensional things and so on of why this particular choice is made, but it doesn't matter why the choice is made. For our purposes, just remember that positive x is to the right and positive y is down. So we're going to open a new file, and in the new file, the first line that we will include after our comment lines is to import pygame. So import pygame is like import math and the other things that we've seen. This gives us access to all the tools, all the pieces of pygame. So including this is necessary to use any aspect of pygame. And then the next line is one that, for what we're doing today, is not fundamental, but as we get more complex pieces, then it becomes easier to just make sure that they're all working together in one way. And so to make sure that all the pieces are working correctly, we will always go ahead and include this line, which is to start pygame, to turn pygame on basically, and it's pygame.init. So we initialize all the necessary components. Okay, the next thing is we're going to create a window to see everything, a window for everything to show up. And so I'm calling this window today, calling it screen. We can call it whatever. This is just a variable, so we have to follow the Python rules for variable names. But pygame.display. So .display has a lot of issues or a lot of aspects related to what we want to see on screen. So we will do a lot of things with pygame.display. And then what set mode does is it takes these values, the arguments that I'm giving now are 640 and 480, so it will give a window that is 640 pixels wide and 480 pixels tall. You can change this value, either of these values, and then you get a different sized window. But the window will always be a rectangle in this setting. We can do other things later, adding captions and all kinds of other things, but right now this is just a basic window to be able to see the preliminary bits. Okay, now that window serves as a surface that we can draw on, but we are also going to create a background. And so the background might be where you put things that you are going to always have that aren't going to change. And so I called it background here. Again, we can have different names for this. And so this is creating what is called a surface in pygame, and the S here is capitalized intentionally. It's part of the name. It's one of those rare occasions that we said in Python where a capital letter is part of the name. And so we could make this background, this surface, different sizes. Sometimes we create surfaces that aren't as big as the screen. Sometimes we'll create surfaces that are different sizes for different purposes. But for this particular case, we want the background to be the same size as the original screen. So if we were to come back here and change the 640 by 480 and had just written that down here, 640, 480, we would have had to change it in both places. But instead, we can use this method to get that information, screen.getSize, and then if we change the size of the screen, the background automatically will change to match. The background is by default created with a black surface. So any surface is created just as a black rectangle. And so we're going to change this for our purposes today to be a white background. So turn the red all the way up, the green all the way up, and the blue all the way up. So the RGB values, all of them all the way up at 255 will create a white background. When we create a surface, maybe we put other things in place on that surface, but after it's done, so right now we just made it a white background. You can do other things, if you're drawing a tree or a house or a street or something that's always going to be there, then you could do that before we put this next line. But this next line, it does some things that will make the drawing later showing up on the screen will make things a little more efficient. And so we do background equal background.convert. This is just a default line. We're not going to worry too much about the reasons right now. We can look into that later. And so this first start is basically the way most of our Pygame programs will start. We'll import Pygame, we'll initialize Pygame, and create the environment where things are going to show up. Right, going on down in our file, we're going to create a starting point. We're going to create a ball that's going to move around on the screen, and so we need to tell the x and the y coordinates. So right now I've just made up some numbers, and let's say we put the center of the ball, x and y, at 295 and 215. What does that mean? The upper left-hand corner is the origin, so we go over 295 pixels, and then in the positive y direction, which is down the screen, we go down 215 pixels, and so the ball would start over 295, down 215, and then we'll proceed from there. We could change these values, put different things in, and you'll want to later just to see what happens, and we'll talk about a couple of other things in a couple minutes that you can do with that as well. All right, something else that we will want is we will want to be able to control the frame rate, and one way of controlling the frame rate is to use the pygame.time clock that is available. So we're creating a clock. Notice this is a lowercase c, and over here is a capital C, an uppercase C. The uppercase C in clock on the right-hand side is necessary. The left-hand side, we're following the typical Pygame Python conventions. So this will create an instance of the clock class. We'll talk later exactly what that means, but the idea of this clock class, we've created a local clock, and then we're going to set frame rate. So FPS, we can set the frame rate to be whatever number we like, and we'll experiment later with this to see what happens when you change the frame rate. But the idea of the frame rate, we're using all caps here, because remember the convention in Python is that if you use all caps, then that means that later in the program you wouldn't want to be changing this value from one thing to something else. We're treating it like a constant. You can change it here to see what happens and find the appropriate frame rate, but once you fix it, once you set it, the idea is that you shouldn't be changing it a whole bunch of times. I mean, Python doesn't stop you from doing that, but we are using this convention with all caps to say, all right, I set it here, and then we leave it alone. All right, then we also need to set a flag to tell us when to go into or when to break out of our main game loop. And so I called the variable main loop today. We can call it other things later, but the main loop, and we want to, when we get to that point, we want to go ahead and go into the main loop. So I'm going to set that flag to be true, and later we can set the flag to be false, and so that we can get out of the main loop. All right, coming back to the x and the y values, what we could do instead of setting actual numbers is we could do things that are based like on the screen size. So we could say ball x is screen.get size, and remember the get size is an x and y value, so that sequence has an index 0 and an index 1. The 0 corresponds to the x, the 1 corresponds to the y. And here, for example, if we, instead of putting 295, we had put something like this in there, then this would start the x value basically a fourth of the way over. If we wanted the ball to be in the center of the screen, we could put a 2. We could put different numbers. And then we could do the same thing with y, screen.getSize bracket 1, and do something in terms of that. So we could have the ball start wherever we like, and it could be a fixed value like we have here with the 295 and 215, or it could be based on the initial size of the screen. All right, so now we have the pieces in place to start the main loop. And so while main loop, and we just set main loop to be true, so we're going to go into this loop at least one time. And remember, this is an indefinite loop then, this while loop. How long we stay in the loop, how many times we go through, will depend on some other features, some other aspects of whatever we include there. All right, so the first thing we're going to do is we're going to put in the clock and have it tick at that frame rate. And so what this does basically is controls how quickly the Python and pygame will go through the loop and how quickly things will happen. You slow that rate down, we'll see what happens. You speed that rate up, and we'll see what happens. Now this line we typically put right here and leave right here. Then if we make other changes, we'll do that down below. This is just a nice convention so that you know where pieces are. All right, now the next thing we want to do then is we want that background to be put into the window. And so when you have a surface and you want to put it onto another surface, the term is blit. So the method that we use here is blit. We're going to put the background onto the screen. So it's screen.blit, and we're going to put the background on the screen. So you name this surface that you want to put onto the other one. So it's not always background onto the screen. Sometimes you put other things onto other surfaces and then put that surface onto something else. And so there can be a series of these kinds of blit statements. What these 00 means right here is the background is a rectangle and screen is a rectangle. And what this says is to put the upper left-hand corner of the background at the upper left-hand corner of the screen. And so the background and screen, remember, are the same size. And so this would put an entirely white background over the black screen that would have been there by default. If you change this value, which you will experiment with doing later, you change this value and it will change where that background shows up. So if you don't want to, if you're not doing an actual background, sometimes you have a smaller surface and so you want to put it where you need it, and we will experiment with what happens in putting it in different places as we go forward. All right, now we're going to draw a circle. And so to draw a circle, we can use pygame.draw, and pygame.draw.circle will create a circle. Now actually what this creates by default is a circle that is filled in. And there's an optional parameter that will allow us to maybe draw a circle with just a border, less fill. But we're going to treat our circle as a ball anyway, and so we want it filled in, and we'll deal with that later. So what do we do when we're going to draw a circle? We have to tell which surface to draw it on. We could, right now, we have two options. We could put it on the screen or on the background. And later, I want you to experiment with what happens if you change these two values. But we're going to leave it on the screen right now. So you say, here's a circle, which surface? The next tuple here is what is the color? So we have the RGB values, and so R is turned off, green is turned off, and blue is turned all the way up. So we have a blue circle that we're going to draw. We gave the X and the Y values to represent the center of the circle, and so we're going to say here's where on that surface I want the center of my circle to be, ball X and ball Y. So which surface, what color, where on the surface, and then this last value is the radius of the circle that we are drawing. The extra optional parameter that I said we can do is we can set that to make the circle like be an open circle, or in this case we have the whole circle filled in entirely in blue. Okay, so then after we have drawn that, we're going to update the X and the Y values. So we're going to say ball X is the old value plus 5, and we'll do the same thing with the Y value, the old value plus 5. So the idea here is that when we put the ball on the screen in one time through the loop, it will be in one place, and the next time through the loop, the idea is that the X value will be 5 bigger and the Y value will be 5 bigger. And so it will look like the ball moved from one place down and to the right, like on a diagonal, to another place. Now, what really happened is it will have drawn in one place and then draw in another place. But if our frame rate is appropriate and that distance apart isn't too big, our brain will fill in the gap, and we will imagine that that ball had moved through all the places in between. Instead, it was at one place, and then it showed up, another circle was drawn somewhere else, but it looks like to us fools the brain into believing that the ball moved or that the circle moved to all the points in between. Of course, there are infinitely many points in between, and we're only drawing a finite number of those, but it doesn't matter what happens on the screen. It matters what our eyes and brain perceive to have happened in this kind of setting. All right, now that idea of drawing something and then drawing it again somewhere else and then drawing it again somewhere else and then kind of flipping through, you may have, when you were younger, drawn some animations like on a corner of a notebook. You draw a picture, and on the next page you draw a picture that's almost exactly the same, but one little part is moved a little bit. You moved a hand, and then you moved a hand a little bit more, and the hand a little bit more. Draw enough of these pictures, and then you flip through, and you get that animation. And so pygame.display.flip flips through these, and this is when you actually see what's showing up on the screen. So when you blitz something, or you say draw a circle, those don't immediately show up and visible to you. This happens behind the scene. When do they show up and become immediately visible to you is when you include a display.flip. Now, there's a couple of other options that we'll see later that you can do, but for our purposes right now, we will just flip, and that will basically show the whole page again, and then the whole next page, and the whole next page, and so on. All right, and so this, if we were to save right now and run, this will work. We will see a ball, and we will see it moving across the screen. Unfortunately, what would happen is when the ball gets to the side of the screen or to the bottom of the screen, the calculations keep going, but we don't see it anymore because it's off the screen. And so we're going to add in a condition to change some things if the ball gets to the right-hand side of the screen or to the bottom of the screen. And the reason we're only focusing on the right-hand side and the bottom is because the ball right now is moving to the right and down. And depending on where we started, it may run off the right-hand side or it may run off the bottom. But since it's not moving left or up, right now we don't have to worry about those sides of the screen. So what happens if the ball gets too far over to the right? Well, remember that the radius of the ball was 25, and so if the center of the ball gets past 615 in the x direction, the right-hand side of it will be past the 640 that we had set. And so if the right-hand side of the ball starts to go off the screen, or in the bottom direction, moving downward, 455, if the ball center is at 455 and the radius is 25, then that means that the bottom of the ball is starting to move off the bottom of the screen. If either of those happens, in this particular case, let's just set main loop to be false. If we set main loop to be false, when we get to that point, then we come back to the top of the loop and main loop is false, and so we don't go back in to the loop. We'll skip to whatever comes after that. If we have the ball still on the screen, then this conditional statement would be a false statement, so main loop would stay true, and we would go back and keep going until we eventually run off the bottom or the side of the screen. And so when we get out of the loop, the response then is we include this line that says pygame.quit. Remember, we initialized pygame, so we started it, and now we are stopping it. So pygame.quit will then, when you save this and run it, you'll see what happens. But when you run a pygame program, we have the file here. It will open the shell, and then we created a window, so it will open the new window. With pygame.quit, it will close that new pygame window that we created. We could do some things like adding in a timer so that the window stays open for a little while, and we can do all kinds of other things that we will see later. All right, now if you save that and run it, you'll see what happens. We're going to make a couple of changes to the program and see ways to slightly improve on this. All right, so going back to our file, we're going to keep certain parts of it, and then we're going to change some places here where I've left some gaps. So one thing we can do is, rather than saying that the x and the y are changing by +5 every time, we can use an idea from maths, from calculus, this idea of dx, which is corresponding to a delta x, which means a change in x. So you may remember from an algebra class, when you talk about slope of a line, you have a change in x and a change in y. We are using that idea here. We could say dx equals 5, and we could also say dy equals 5. And then down here, instead of saying change the x and the y values by 5, we could say change them by dx. Well, right now that's going to behave exactly the same way as what we just did. But what if we changed one of these to a different number, or both of these to different numbers? Maybe one of them make it a 3 and the other one make a 2. We can see what happens here. But again, that doesn't really change overall in terms of what we did before. We could have just put different numbers in here. But let's think about what would happen if we got to the bottom of the screen, for instance. If we get to the bottom of the screen, what do we want to do? The ball is moving, so let's say right now, down and to the right. When it gets to the bottom of the screen, we want the ball to bounce off. So for it to bounce off, we still want to continue moving to the right, but now instead of moving down, we want to move up. And so what we can say is, if the ball y value gets too big, remember this too big would put us at the bottom of the screen. The screen is 480 pixels, and so 455 plus the 25 would put us the ball starting to go off the bottom of the screen. If that happens, then we could, for instance, change dy to negative dy. If we just had the numbers in here and didn't have dx dy, then it would be a little more difficult to change that to change that value. Not actually, but in terms of the general sense, sometimes rather than it being specific, that particular number, sometimes we will want to do things where we change the dy to speed something up or slow it down. It hits the wall, so it slows down a little bit, hits something, so it slows down, but then something else happens and it speeds up. And so we will usually control dx and dy in this way, rather than being a specific value and just say, oh, change it by this much, change it by that much. Right? So if we just had the numbers 5 here, then it doesn't work as well in terms of saying, oh, let's turn this around, and now instead of adding 5, let's subtract 5. But with dx dy, we can have that control going on. So if you save this and run this at this point, the ball gets to the bottom of the screen, hits, and bounces off. Now, nothing, if it gets to the right-hand side of the screen, it just keeps on going and runs off the side. And if you let this run too long right now in pygame, then you will have this issue of it's expecting interaction. Pygame expects the user to interact. And if it goes too long without interaction, then it will freeze up. And the only way to get it to stop with the freezing up is to close the shell window that had opened. If you close the shell window, you'll get this warning of, oh, your program is still running. You go ahead and stop it, and then it'll close the shell and the pygame window. Because right now, notice we replaced that condition that would have ended the window, that would have set main loop to be false, we replaced it with something else. All right, so as far as the user interaction is concerned, we're going to keep everything that we just did, but we're going to move it all down except for the clock, right? So the clock we usually leave right here at the top again. I didn't include it here, but we normally leave the top the clock at the top of the loop just out of habit. All the other pieces that we just had, we're moving those down and we're inserting this in its place. So we're looking for user interaction now. And so Pygame has this event.get method that checks to see if certain events are taking place. And the kinds of events we're talking about are right now keyboard or mouse things, right? Did somebody press a button? Did somebody do certain things? Did they use the mouse? Did they move the mouse? Did they click the mouse? Did they release a button? Did they click both buttons? All kinds of different possibilities. And so we're going to create this loop that is going to look at all of those different things that could have happened and then check what kind of events are occurring. So if the event.type, so if the thing that happens is the pygame.quit situation, well, pygame.quit, notice this is all caps because, again, that has a specific meaning. Pygame.quit is, did the user click the X in the upper right-hand corner of the window? If the user clicked the X, then we want the main loop to be false. We want this thing to stop. Now, it won't stop immediately. It will just it will say the main loop is false, and it will go on down. It will continue checking other events, and then finish that loop and still be in the main loop and do the final drawing part. But if we want to set that to be false, right now we could break out of the checking for other events. If somebody clicks the window, stop checking for other events, let's just go ahead and break out of that. Draw what's left to draw in that part of the loop, and then main loop is false, and so it will end the main loop, and then we have the pygame quit. So if somebody clicks the X, then the window will close very quickly. There still might be one more frame of drawing, but it will then terminate. That's one way. You could click the X to get out. Another kind of thing we could do is say, well, if the event.type was not pygame.quit, what if somebody pressed a button? If somebody pressed a button, then we can do things. And so there's lots of things you could do with the key down, and we will do lots of things. Left and right arrow keys, up and down arrow keys, any button that's on the screen. We can do user control with the WASD. Lots of other things you can fire by pressing the space bar or doing whatever kinds of things you want to do. All different possibilities. We're just going to look at one right now. And so if somebody presses a key, well, if the key happened to be the escape key on the keyboard, so the escape key on the keyboard is named K_escape. This is all caps. We'll get a whole list of these for looking at the different values. But if somebody presses the escape key, what do we want to have happen? Well, the same kind of thing. We want main loop to be false, break out of that, stop looking for other things, and go ahead and end the loop. So main loop false, and a break here. Again, the break's not necessary. We're just including it to show another use of break. Break gets you out of the loop that you are in. And right now we are in a loop inside another loop. And so the break breaks us out of the for loop and tells Pygame to stop looking for other activities, stop looking for other keyboard interaction, stop looking for other mouse interaction. Okay, so if the rest of the code then is down below, still inside the loop. We just added in these new pieces. And now what happens if you save this and run it? You have the ball moving around. Right now, what we have is it bounces off the bottom. But if you click the X in the upper right-hand corner, or you press the escape key, then it will terminate. It will close that window, and Pygame will quit. All right, now it's time for some experimentation. So we have created lots of pieces in the program, and we want to go back and see what happens if you change something. Change one thing, save it, run it, see what happens. For instance, we can do things like changing the frame rate. Try 60, try 120, try 5, try different values. Try float values and see what happens. Just try different things and see what happens. Maybe as you try a couple things, then before you try something else, try to anticipate and guess what you think it will do. See if that's what happened. If it is, then that kind of helps confirm your understanding of something. If something completely different happens, then that gives us a way to try to learn something new. I wonder what happened. And then you say, why did that happen? And then you say, well, what I thought was going to happen isn't what happened. How can I make the thing that I thought was going to happen? What do I need to change for that to take place? So let's experiment and just see what we can do. Other things we can do is maybe change the background fill color, change the color of the ball, see what happens later. We're going to do things like as the ball bounces off the walls, we're going to make it change color each time. And so when we imported Pygame at the beginning, we'll import other things, maybe import math, import random, import some other things, modules that we will work with and learn about. And do various things to happen. Maybe we make the size of the ball change. Lots of different things that we will do with this as we go forward. But right now, let's just change the pieces that we have. Don't worry about what we can do in future. Just changing the specific values that are in place now. And we want to try to get the ball to bounce off all the sides. Right now, we put in how to get it to bounce off the bottom, but the right-hand side, the top, the left-hand side, because now when we had it bounce off the bottom, before we just had to worry about it going to the right or down. Now it's going to the right or up. If we get to the other side and it bounces off, then we have to worry about now it's going to the left and up. And so again, all of those situations could happen. The nice thing about the approach that we took on the bouncing is we don't have to do calculations of like what the angle actually is. You just change the value and the angle automatically works out for us. And so a lot of times we're able to make things mathematically correct and then sometimes even realistically correct or nearly so, and not have to do all of the math. Sometimes we can do a lot less. Occasionally we have to do more. And so we will explore those different situations. In real life, what happens if you have a perfect mirror, let's say, and a light that hits, then it's going to reflect back at the same exact angle that if it came in at an angle like this, then it's going to bounce off in the same way. In real life, if you throw a ball at a wall at an angle, then the ball might be a little flat, so it slows down and maybe doesn't quite work exactly the same way. Maybe the wall has a little bit of a roughness to it or something, and so it doesn't bounce off perfectly. If you've ever played pool or billiards, You hit a ball off the rail. If the rail is a little bit damaged or the ball is not perfect, it doesn't do exactly what you wanted necessarily. Sometimes you hit something and then it should slow down as it goes away instead of just bouncing off at exactly the same speed. Maybe it should slow down a little bit. And so all of those kinds of things we can experiment with just by changing the values that we've already talked about. We've already mentioned the idea of different dx and dy values. You could change them in all different ways. You could try things like what happens if one is positive and the other is negative. We've already seen the idea of what that would do. What if you try a float to see what happens if dx and dy are float values rather than integer values? What if one of these is 0? What would happen? So try different possibilities and see what the effect is on the action of the ball. What happens if something breaks? Well, then we just change it back and keep on going. You can't really break anything, right? Just Python will yell at us for a little bit. But otherwise, just experiment. Try a bunch of things and see what happens from this basic starting point of here's a ball somewhere on a screen, starts moving around. Oh, now it starts bouncing. Now other things start to happen. And so this kind of corresponds to our version of hello world, right? This is the make something happen, right? Put something on the screen, make something happen with that. All right, so as usual, feel free to ask questions in the comments, by email, on Discord, or any other way that you might like to ask questions.